The shift starts at 5. By 4:45, the Cat 789 is already running. Engine pre-lube cycle completed. Block heaters have been on since midnight. The temperature outside the cab is -29, and the Cat 3,516 diesel 16 cylinders, 4 turbochargers is turning over at low idle, building heat through its own mass before the operator takes the seat. There is a particular sound to a 789 at idle in winter, lower than you expect for the size of the engine. A steady, even pulse that does not suggest the 1,705 horsepower available when the transmission engages and the truck begins to move. This is northern Alberta. This is the Athabasca oil sands. And this machine, not the largest truck on site, not the heaviest, not the newest, has been running this haul route in some form for the better part of a decade. The Cat 789 was introduced in 1986. It was not built to set records. It was built to work, to load and haul and dump and return, 12 hours at a time, 24 hours a day. In conditions that required every design choice Caterpillar's engineers had made to earn its keep over and over again. It earned its keep. Before we go further, if this kind of history matters to you, consider subscribing to the channel. Every video here is built around the machines and the men who ran them, the haul trucks, the shovels, the open pit and oil sands operations that fed Canadian industry for decades. If that's worth documenting to you, the subscribe button is how you tell us. And we want to hear from you. Did you work in a Canadian mine, open pit, oil sands, underground, maintenance shop, processing plant? Did a father or grandfather drive, haul trucks, operate a shovel, work the blast crew? Did you grow up in a mining town? Fort McMurray, Sudbury, Timmins, Trail, Flin Flon, or somewhere up in the territories? Leave it in the comments. The people who actually work these operations know things that don't appear in any company report. We want to hear from them. Now, back to the operation. The Cat 789 did not emerge from a blank brief. Caterpillar had been in the off-highway haul truck business since the 769 introduced in 1962 with a 3.5-ton payload and a mechanical drivetrain that set the design philosophy the company would carry forward for decades. The 777, introduced in 1974, moved the goalposts. 100 tons of payload, 870 horsepower, a machine that proved mechanical drive could compete at scale. By the early 1980s, the oil sands operations in northern Alberta were demanding something larger. A truck in the 150 to 200 ton class that could reliably handle the Athabasca's specific combination of abrasive silica, sand, frozen haul roads, steep bench grades, and the continuous 12 hours on operational cycle. The 789 was Caterpillar's answer. Introduced in 1986, it arrived at 177 metric tons of rated payload. The engine was the Cat 3,516, a V16, 4-turbocharger, 4-stroke diesel, producing 1,705 horsepower, fully mechanical drive, power shift transmission, oil-cooled disc brakes on all 4 corners. The mechanical drivetrain was a deliberate choice. In the oil sands environment, where temperatures at -30 could compromise electrical insulation, and where silica-laden air was an enemy of electrical components, a machine with fewer systems to fail was a machine with more hours on the haul road. At 177 metric tons of rated payload, a fully loaded Cat 789 had a gross vehicle weight in the range of 330 tons. The Cat 3,516 engine displaced approximately 69 liters across 16 cylinders. 4 turbochargers compressed the intake air to maintain power output at altitude and in temperature extremes. High displacement, conservative, RPM rating. An engine producing power without running hard. Because an engine running at the top of its rated RPM is an engine consuming its service life faster than one running with headroom. The brake system on the 789 was oil-cooled multi-disc on all four corners. The oil cooling was critical. On a steep downhill haul with a full load, the braking heat generated across a 12-hour shift would destroy conventional brakes in a fraction of the time. The oil-cooled discs dissipated heat continuously and maintained consistent brake response, regardless of how many downhill runs the truck had made in the preceding hours. The tires ran large, sized to match 789's footprint to what the oil sands haul roads were engineered to carry. Tire wear on the Athabasca site ran faster than almost any other application the manufacturer had documented. The silica content, abrasive at any temperature, but particularly aggressive when frozen, and being driven over at haul road speeds, ate at the tire compound in ways that required monitoring and rotation scheduling to manage. The oil sands environment tested every design. Decision the 789 represented. The pre-lube system ran before cranking to prevent dry start wear. The block heaters maintained coolant temperature through the night. The electrical starting system drew from a heavy-duty battery bank that cold weather reduced in capacity. Standard engineering response in the Athabasca was to specify batteries rated higher than the manufacturer's minimum to retain adequate cranking power. Once running, the 789 required careful management through the first 15 minutes before the transmission oil reached operating temperature. An operator who pushed a cold 789 hard on the first loaded climb was an operator working against the machine. Fully loaded on the Athabasca grade, approximately 8% on the primary bench roads. 789's mechanical drivetrain earned its design justification. The power shift transmission managed gear selection to keep the engine in its torque curve. No torque drop-off between gears. The 1,705 horsepower pulled steadily. The tires held their grip on the compacted frozen road, and the machine climbed. The oil sands themselves were the persistent challenge abrasive to the truck body liner, the tailgate, the tire compound, the suspension bushings. Sticky in summer, frozen in winter. The 789 handled all of it. Not easily, but consistently. A cat, 789 inches, the Athabasca oil sands, was not a machine you got in and drove. It was a machine you managed. The shift pre-inspection was the first maintenance event of every shift. The maintenance culture was built on interval-based, scheduled service. Every 250 hours, oil and filter changes, fluid system inspection, undercarriage lubrication. Every 1,000 hours, drivetrain and braking inspection. Every 3,000 to 4,000 hours, the major overhaul that rebuilt the engine and transmission to service specifications. At those overhaul intervals, the 789 was not scrapped. It was rebuilt. Engine out, transmission out, frame inspected. A 789 that had completed its first major overhaul went back onto the haul road as a machine capable of running another full service interval. The men who maintained them, the mechanics who worked the maintenance bays at -30, with engines out of trucks, were part of the same production system as the operators on the haul road. The truck that came out of the shop was the truck that met the morning shift production target. The Cat 789 outlasted the era that produced it. When Caterpillar introduced the 797 inches, 1,998, the 360-ton ultra-class machine, the 789 did not disappear from the oil sands. It stayed. The 797 handled the primary haul cycle. The 789 handled secondary work, overburden hauls, maintenance roads, operations where a smaller, more maneuverable machine made better sense. The 789 went through successive variants, the B, the C, the D, each generation refining the engine, the transmission, the cab, without changing the fundamental design philosophy. Mechanical drive, high displacement, conservative RPM, oil-cooled brakes. A machine built to be rebuilt. Some of the 789s that worked the Athabasca in the 1980s accumulated service lives, measured in cumulative tons, hauled numbers that represent a significant fraction of Canada's oil sands production during those years. Each cycle was 177 tons. Each haul was 12 to 15 minutes. Each shift was 12 hours. Each truck ran for years. Do that arithmetic, and the machine's contribution stops being abstract. The CAT 789 was not a monument. It was a tool. A tool that earned the trust of the maintenance crews who kept it running, the operators who drove it in conditions. Those machines were not designed to make comfortable. And the production managers who planned their daily targets around the assumption that the 789s would show up and do the work. They showed up. They did the work. If this is the kind of Canadian mining history you want to keep watching, subscribe to the channel. There are more machines, more sites, and more operations still to document. And if you have a connection to what you just watched, a family member who spent their career in a pit or on the patch, a grandfather who ran one of these trucks in northern Canada, someone who was there when this era of mining was still running, tell us in the comments. What did they operate? Which site? What do you remember them saying about the work? The men who ran these machines didn't leave many records behind, but the people who knew them are still here. We want to hear from them.